All right, we're going to finish up going through these molecular shapes. But here, well, let's just say we're doing molecular shapes still. And this time we're going to just stick to 6 things. Okay, and we'll start right at the beginning with 6 atoms. Okay, and basically that's going to be review, hopefully. So 1, 2, 3, 4, 5, and 6. And hopefully you remember what the name of the shape in the bond angle. All of these are equivalent. There's no equatorial axial here. They're all exactly the same. And they are 90 degrees from each other. And they are all octahedral. Octahedral. And a good example of this would be SF6. And SF6 is kind of an interesting molecule. I just don't want that to be the same color, sorry. SF6 is an interesting molecule. It's a gas. It is denser than air. And you know how helium makes your voice really high and squeaky when you inhale it? SF6, sulfur hexafluoride, makes it really deep, like your Barry White, if you know who that is. And it's kind of a funny thing chemists sometimes do. But I've read that because it's so dense, it doesn't actually leave your lungs very easily, and it just sits in the bottom of your lungs, so maybe not the best thing to do. But you can Google somebody inhaling SF6 and hearing them talk really deep. Anyway, we're going to move on, and we're going to talk about 5 atoms, 1 lone pair. Okay, here it doesn't matter where we put that lone pair. So let's just go ahead and do that. You can put it literally anywhere. I just picked that spot. That was kind of sloppy. And just so you know, when you do take OChem, the shapes are really, really important, and learning how to draw them is actually really important as well. Okay, so this shape is, we have a little square down here, and I don't know if you can see, I don't know if it'll help if I connect this like this, but it forms a pyramid with that atom at the top. So hopefully that looks okay. And that is square pyramidal. Square pyramidal. And a good example of a square pyramidal molecule is ClF5. So chlorine in the middle, fluorines all around, except for that one position. Okay, so the biggest thing you guys need to learn to do is you need to look at a Lewis structure and you need to recognize, oops, that should have been a fluorine. You need to recognize what the shape is based off the Lewis structure. I'm not going to have you draw them. You need to be able to look at your Lewis structure and get the shape, okay? So there's square pyramidal. And then moving on, we are going to have 4 atoms and 2 lone pairs. Okay, now again, it does matter where we put those lone pairs, because we had 1 lone pair in the square pyramidal up above, and we got to minimize the repulsion. So we're going to put it exactly opposite where the first lone pair went. Okay, so it's going to go on the top of the pyramid there. So central atom, lone pair, and like I said, put that other lone pair exactly opposite atom, atom, one more, And this isn't a square pyramid, it's just a square. Okay? But because it all lies on the same plane, we call this square planar. All right, and a square planar molecule, xenon tetrafluoride. So lone pair, fluorine, fluorine. I think you get the idea, but I'll finish it out. All right, so there's xenon tetrafluoride. And we have one last shape we're going to talk about. All right, so 3 atoms, 2 lone pairs. Oops, I'm sorry, 4 lone pairs. Oh, gosh. Yeah, someday I'll learn to count. 3 atoms, 3 lone pairs, because it has to add up to 6. We're doing 6 things. So now if we look at that square planar, where are we going to put the other lone electron pair? It actually doesn't matter again, because all of those are equivalent. So we'll just pick a spot. Okay. So let's draw that. Let's see. And this one might be a little bit difficult to see, but we'll have a lone pair going up, lone pair going down. I'm just going to put lone pair here. It's somewhat arbitrary where we decide to put it in our drawing. But again, if I highlight those atoms, what does that look like? Well, that's a T shape. Again, it's T-shaped. Notice we can get T-shaped 2 different ways. Okay, we can get linear 2 different ways. We can get bent 2 different ways. So you really got to practice these to be able to not get them confused with each other. All right, and if we have xenon trifluoride, but it's an anion. Okay, so let's see. Try and draw it the same way I drew the other one. Fluorine. All of its lone pairs. I can hear my dog outside barking at the wind. Dogs are so goofy. Okay, and again, we got that T shape. Oh, it's an ion, it's an anion. So we cannot forget the brackets and the charge, okay? Has a -1 charge. So that's it for those molecular shapes. You got to know those shapes, all right?